Okay, and we're live in 3, 2, 1, go. Okay, welcome to the Mentally Mathly. Please kindly take 5 minutes to complete, so pause the video. We'll see you soon. Okay, here we go. First question. This is the old trickaroo question. 7 friends decide to go to a movie. Determine how many ways the friends can sit in a row if 2 of the friends refuse to sit next to each other. Uh-oh, that sucks. Well, the easiest way to do this one, if you guys remember from yesterday, is figure out all the ways. And then to subtract the ways that they can sit together. And then that will give you all the ways they don't sit together. Just like Mama's pumpkin pie recipe. That doesn't make any sense. Here we go. Okay. So, how do we do it? Well, if it's 7 people sitting in a row, all the ways they can sit together, that would be 7 factorial. And the ways that they can sit together, well, that's going to take a little bit more work. So we're going to go up here. And we're going to go 1, 2, 3, 4, 5, 6, 7. Okay, now the way to do this is to group 2 people together. Okay, so within this group, there's 2 factorial ways that those guys can sit. And then you consider each thing as a group. So like this is, as a person. So this is a person. So it's 1, 2, 3, 4, 5, 6. So then there's 6 factorial ways that we can move this through. So that'll be that. And yeah, we're done. We just got to actually calculate those 2 numbers. I cleverly don't have an answer, but give me a second. Get my calculator. Ta-da! Okay, let's go 7 factorial minus, better use some brackets to be safe. All right. Wow, that's a lot of ways to not be friends. There's 3,600 ways we're not friends. Perfect. Only math nerds would say that. Moving along. You've forgotten your code to your cell phone. Oh no! You know the code is made up of 4 numbers from 0 to 9. Determine the number of possible codes if repetition's allowed. Well, that's a fun one, because it's just 10 times 10 times 10 times 10, right? So there's your first number, second number, third number, fourth number. So that's a 1 with 1, 2, 3, 4 zeros. Okay, yeah, 10,000 codes. Okay, ooh, a trig question. This will be fun. Right, so over the interval 0 to 2 pi. Well, this bad boy, 2 problems. You gotta factor it, and it's cosecant. So you can get rid of the cosecant at the end, and you guys are the most cleverest class I've ever had. So you know that 1 over sine theta, you know that's cosecant. So first we'll factor, then we'll substitute in. So this is an easy factoring one, so to speak. So we're going to write cosecant theta, and then my 2 magic numbers that multiply to -8 and add to -2 are -2 and +4. Okay, so now I'm going to go ahead and solve this one. Equal to 0, so I'll get cosecant theta equals -4, and I'm going to get cosecant theta equals 2. And oh boy, I'm now going to substitute in 1 over sine. All right, so I'll do it for this one when I substitute 1 over sine theta equals 2. There we go. I know that, well, I'm just going to cross multiply. So at the end of the day, you're going to get sine theta equals 1/2. So remember, it's the same thing as doing the reciprocal of 2. So over on this side, I'm just going to go straight to sine theta. I'm going to do the reciprocal of this, and I'm going to get -1/4. Okay, so this is not an exact value. So when I find my inverse sine here, I'm going to go ahead and plug it in on my calculator. So I actually get theta r equals 0.2527. And I'm solving over 0 to 2 pi. So here's 0, here's pi, there's 2 pi. Fun, fun, fun. And I'm looking for where sine theta is negative, so that's going to be quadrant 3 and quadrant 4. So in quadrant 3, I'm going to go theta equals pi plus my reference angle. Okay, then in quadrant 4, I'm going to go 2 pi subtract the reference angle. Okay, just a quick reminder, there's the sketch. There's my reference angle in quadrant 4. So it's clear I got to go 2 pi subtract the reference angle. Oh boy, answers, answers, answers. So the first one is 3.3943. Second one is 6.0305. Now remember, if the exam doesn't specify, they want at least 3 decimal places. So I'm actually good with 4. Okay, we can go back here and we can go sine theta equals a half. Well, that's an exact value. So when I do inverse sine of a half, I know that I'm just going to get pi over 6. Okay, then I got to think about the quadrants where sine is positive. So that's quadrant 1 and quadrant 2. So one of my answers is pi over 6. The other answer is going to be over here where my reference angle is pi over 6, quadrant 2. So that's going to be 5 pi over 6. And we are done. Give yourself a frickin' pat on the back for doing that. Okay, so I'm not here today, but I basically am with you guys in spirit, because here we are doing the notes, even though I'm not here. We're doing combinations today. So quick recap. Yesterday we looked at permutations. That was this formula here. Okay, so that's a permutation. So we learned what a permutation was, and we knew that order was important for permutations. Okay, so if the order of the things needed to be in a specific order, that's where you're going to use a permutation. So yeah, that's what that second sentence basically says. If you want to just find out how many ways you can choose objects without necessarily arranging them, so without really worrying about the order too much, that would be something that you would use a combination for. Okay, so let's take a look at the difference here. Let's take a peek. So in the first example, we got how many ways can you choose a student council if you got a president, vice president, secretary, and a treasurer out of 9 candidates? Well, you're going to go, well, there's 9 people, okay, and we are going to pick 4 of them. Now you go ahead, you type that into your calculator, and you're going to get 3,024. Okay, or remember, the other way to do this question is you can say, well, I need 4 people. So you draw 4 spaces and you say, well, when I pick the first person, and it doesn't matter, we can just say, let's say, it really doesn't matter, right? Like you pick, you got 9 people to choose from. So you go 9 for the first position, whatever it happens to be. And then you used 1, so you got 8 left, and then 7, and then 6. If you do it this way, you will actually get exactly the same answer there. Okay, so that's a permutation question. Now, let's look at example 2. So it says, how many ways can I choose a committee of 4 people out of 9 people? Okay, but in this example, I'm really concerned about specific people this time. Okay, so if we have Tom, Joe, Sue, and Betty, and we choose those 4 people for the committee, well, that's not any different than choosing in a different order the same people. So if I choose Joe, Betty, Tom, and Sue, it's still the same 4 people. It's in a different order that I chose them, but it's still the same committee. Okay, so you see the difference? In here, these are specific positions. Okay, so the order that we pick them in matters, right? For example, this might have been the president. This might have been the vice president. This might have been the secretary. That might have been the treasurer. Okay, so the order that you get the names here, that matters. Okay, in this one, it just says, hey, four people in a committee. Okay, so it doesn't matter what order we pick the committee, everybody's the same in this one. Okay, so very, very small distinction. And for something like this, we actually use something called a combination. Okay, so what a combination does is it gets rid of all those groups that are the same. Okay, so it gets rid of Tom, Joe, Sue, and Betty, and Joe, Betty, Tom, and Sue is this the same thing. So if you try this on your calculator, okay, so that's the combination right there. We'll go over the formula in a second, but if you just try typing that in, I'll write it out using the formula. So it's actually very similar to a permutation. So it's the 9 in the numerator, and then you go 9 minus 4 factorial, and then the extra thing is that you toss in an extra one of these, you go an extra 4 factorial. So that gets rid of all those extra cases. When you type that all in, you're going to get 126. Okay, so if you compare them, the formulas, here's a combination formula with an extra 4 factorial. Let's go back. Ooh, oh, I didn't write down the formula. Well, the formula for this one would have been 9 factorial times or divided by 9 minus 4 factorial. Maybe. Okay, so there's the permutation formula. There's the combination formula. Permutation, combination, permutation, combination, permutation, combination. Okay, little bit of difference right there. Okay, what's the formula, you ask? Well, here it is. So in this one we say, well, if the order doesn't matter, as in like getting the same 4 people in a different order is the same thing. So if the order doesn't matter, it's a combination. Here's the formula. Okay, so if I cover up this little thing right here, that's a permutation formula. That's the combination one. Permutation, combination, permutation, combination. Okay, one more time. E. Okay, great. So the r factorial on the denominator is for the arrangements of the identical items, which is no longer important for a combination. Okay, now this is just brutal. Okay, it is sort of tricky to be able to tell the difference between these problems. Your best defense is doing lots of problems and doing them correctly so that you can see the difference. So let's go. First, we'll just do a couple no calculator questions because every once in a while it comes up on the exam. So just a reminder, the formula for combination is very similar. There it is. Okay, so when we do this one here, we're going to go 8 factorial divided by, I'm just going to do it the quick way, so n minus r, that would be 6 factorial, times r again, which should be 2 factorial. Okay, you can type it in on your calculator or reduce it out. You get 28. Okay, let's look at this one over here, because we're going to notice something in a second. So this is 8c2, this is 8c6. So watch what happens when we write it out. Well, the numerator is the same. Okay, in the bottom, when you go 8 minus 6, you actually get 2 factorial, and then we do another r factorial, which is 6 factorial. Okay, and look at this. Look here, look here. What's the difference? Nothing really, just the 6 and the 2 change places. So you actually get 28. Okay. Interesting. Let's do another one. Okay, so we'll do 7c3. So this would be 7 factorial. And then in the bottom, 7 minus 3 is 4. So you get 4 factorial, and then you do a 3. You get a 3 factorial. Oh, okay. So if you do some work, you'll get 35. Perfect. Let's look at this one. So it's a different combination. Okay, the n value is the same. So we go 7 factorial. When we go 7 minus 4, we get 3 factorial, and then we do another r factorial, so another 4 factorial. Oh, let's look. This one and this one. The denominators are actually the same. Different order, same combination. So what's going on here? It says, well, what do you notice? This should make sense if you look at the formula. Well, we notice that these two actually had the same answer because the denominator was the same, just backwards. It does make sense if you think of the formula. The n minus r and the r factorial just happen to work out to the same numbers, just in a different order. So what does this mean for us? It's not really obvious, but check this out. If you're comparing combinations, okay, and these two numbers here, the r values, if they add up to the n value, okay, and the two n values are the same, then the combination will have the same answer. Every once in a while that comes up in the theory part of the exam. Okay, so check it out here. 3 plus 4 is 7. So I know that these two combinations will actually be identical. Okay, so maybe we can summarize that. If r values add up to the n value, the combinations, and I'm just going to write combs or combs, don't get confused. The combinations are the same. Neat. All right, flip it a page. So this question got a little messed up. It should actually read, therefore, what would 14 choose 3, and then it's all messed up, but that's supposed to be a fraction line, divided by this one over here. So we'll just copy it over here and get rid of that. There, it's like it never happened. So if I had 14 choose 3 divided by 14 choose 11, what would it equal? Okay, and this would be given on the non-calculator part of the test because it would be a nightmare to try to calculate it out. Okay, so the thing you're supposed to notice here is that, okay, so both combinations have the same n value. So that makes alarm bells go off. Then you check, well, do the r values add up to the n value? And it does, because 3 plus 11 is 14, which is the n value. So that means that these are the same. So if I'm doing one number divided by itself, well, then the answer is 1. All right. Remember, you are the only one who can do this. And everyone else in the class. Okay. Combination question practice. Here we go. So we're going to do basically a bunch of examples, hoping that it's enough in conjunction with the homework that you'll, be okay. So, the Lotto Max, one of my favorite games to play, is Canadian Lottery, where a player chooses 7 numbers from 1 to 49. Okay? So to win the jackpot, all 7 numbers must match the drawn numbers. Well, how many combinations of 7 numbers are possible? So sometimes they're cheesy. Be very careful. I've seen it on the exam where they use the word combination in a question. It's just nasty, and it's a permutation question. Okay, so just because you see the word combination does not mean that you're going to use combinations. Let's think for a second why this is a combination. Okay, so the way to win this game is you just have to match the 7 numbers that get drawn to win the jackpot. So let's say that the numbers are 1, 3, 5, 6, 7, and 10. Is that 7 numbers? No, it's 6. Silly, DeMiro. Okay, let's say those are the winning numbers. Okay, so the way the game works is it doesn't matter what orders the numbers are drawn. It's just, do you have on your ticket the 7 numbers that got drawn? So this could be the winning combination of numbers. So let's write jackpot. Okay, now if I chose my numbers in the opposite order, so I had 11, 10, 7, 6, 5, 3, and 1, I would be a winner. Why? Because the order that the numbers are on my ticket doesn't matter. It just matters that I match the 7 numbers. Okay, so that's why this is a combination. Okay, the order doesn't actually matter. These are actually considered to be the same thing. Okay, so with that out of the way, it's actually an easy question. So once you realize it's a combination, well, you say, okay, well, I got the numbers 1 to 49. Okay, so there's 49 numbers to choose from. Okay, and so I'm going to write combination there. And I just need 7. So I go 49C7. And generally these will pop up on the calculator part of the exam. So when you type that in on your calculator, I do recommend you give it a try. You're going to get 85,900,000, that's a 9, 584. Okay, so why am I sort of silly to play the Lotto Max? Well, if I buy 1 ticket, I have a 1 out of basically 86 million chance. So you'll notice on the Lotto Max, a lot of the times, population in Canada is about 35 million. If everybody buys a ticket, you still wouldn't expect a winner. So you'd have to sell about 86 million tickets before you'd expect 1 winner, is another way to look at this. So that's why often you get draws that go on for a few weeks before anybody actually buys a winning ticket. Your chances of getting hit by lightning are about 7 times higher. Another fun analogy I heard was, imagine that you're in a football field, okay, and you got 1 ant in the field and you have a tiny little pin. The chances of you taking that pin and randomly stabbing it in one spot in the field and hitting the ant is actually higher than you winning the Lotto Max. So, there you go. Should just take those $6 and buy DeMiro a coffee. A fundraising committee is to be chosen from a group of 8 students. Okay, so be careful. Anytime you got a committee question, usually it's a combination, right? Because the order that you pick the committee doesn't matter. Okay, so if I'm going to pick 5 people on the committee, it doesn't matter what order I get them in. It's going to be the same committee. So it's going to be 8C5. type that in on your calculator, and you get 56. Okay, and again, remember, you can use the formula, but obviously don't if you have your calculator. How many ways can a committee of 3 students be chosen? So that's going to be 8C3. And now, you should know the answer is 56 really fast. Why? That's that stupid trick again, right? The n values are the same, and it just happens that the r values, when you add them up, add up to 8, so we know that it's going to be the same. If you didn't notice it, it's okay. I forgive you. Next questions. Here we go. What do we got? In how many ways can 6 teams in a league play each other team only once? Okay, so if you think about this one, it's a combination because it doesn't matter who plays who first as long as every team plays every other team only one time. Okay, so you could sit here and think about this question for a long time, but once you realize that, then you're like, well, then it's a combination. So I'm going to go 6, choose 2. And you know what? We haven't written out the formula, so I'll write it out once. Be good to practice. Let's reduce it down by hand. So 6 factorial is 6 times 5 times 4 factorial. I'm going to stop there because now I can cancel the 4 factorial on the bottom. So that cancels out to 1. 2 factorial is just 2 times 1, so you get 2. So you got 6 times 5 divided by 2. Okay, and you can either think of this as 30 divided by 2 and get 15, or you can do some other fancy stuff and reduce the 6 and the 2. Anyways, who cares? You get 15. Okay, there's 10 boys and 8 girls in a class. How many ways can a committee of 10 be chosen? Okay, so this question, there's no restrictions. Ooh, look at that bling bling. No restrictions. Again, it doesn't matter the order that you pick the committee. So I'm just going to say, well, there's 18 people, right? 10 boys, 8 girls. So I got 18, and I need to choose 10 of them. Type that in on your calculator, and you get 43,758. Wow. All right. Last one on this page. 10 boys and 8 girls try out for a co-ed volleyball team. If each player has an equal chance, how many ways can a team of 4 boys and 4 girls be chosen? Okay. This one will require a bit of thought. So the first thing I might do is write this down and be like, okay, the boys and the girls. Okay. Now it says that we're going to get 4 boys and 4 girls, and right, that's what it says. Now, does it matter the order that I pick the boys and the girls? So if I pick all my girls first and then all my boys, is that going to result in a different team? Well, no, because I'm just going to get 4 girls and 4 boys anyways. So that's the first thing to realize. And then I guess the second thing to realize is, yeah, when I'm picking my boys, it doesn't matter what order I pick them in. So if I pick boy A, B, C, D in that order, that's the same thing as picking them backwards. It's still the same 4 guys. So it's a combination. Okay, remember, when we're doing these notes, we know that every question in the combination section of the notes will be combinations. But when you're doing these questions and they're just mixed in all together, you really need to think about, is it a combination or a permutation? Okay, so I'm going to keep on talking about it. So anyways, with the boys, we got 10 boys, and we're going to choose 4 of them. So there it is. And then the fundamental counting principle says, well, we multiply by how many girls. So it said there was 8 girls, and we choose 4. And you can type that in on your calculator, so you can actually type that in just like that. When you do, you're going to get 14,700. That's a lot of ways to not be on the team. All right. Let's do an example where we bring it all together. How many ways can you choose a committee of 5 from 6 boys and 7 girls if you want a majority to be girls? So, oh boy, we're gonna have to think. So a majority have to be girls out of the 5. So some of you guys will struggle a bit. A majority means more girls than there are boys. So this is going to be one of the ones that has cases. Okay, so you can just think of the cases. If there's 5, then the one way of having a majority would be having 3 girls and 2 boys. Right? If I had 3 boys and 2 girls, well, that's not a majority of girls. Okay, so I'll do this case, and then I'm going to add to it another case. Well, I could have 4 girls and 1 boy, right? That's a majority of girls. Or I could have just 5 girls and no boys. That would suck, but there it is. So, option 1. And I guess I'll talk about why is it a combination. Well, again, the order that I pick those 3 girls doesn't matter. So again, girl A, B, C would be the same as picking them in the opposite order, C, B, A, still the same 3 girls. So that's how I know it's a combination. So it said I had 7 girls. So I'm going to go 7C3 times, because the fundamental counting principle says we multiply the ways we can do things. It says there's 6 boys, and I'm choosing 2 of them. So there we go. So when you type that in on your calculator, I'll give you a moment. It's the first time I really gave you time to do it. So hopefully you typed it in. You get to 5 at 25. So underline that. And I'm going to put a box around it. There. Box it in. Now we'll do this one. So very similar. We're starting all over again. We got 7 girls. We're going to choose 4 of them. Times. We got 6 boys to choose 1. Okay, give you a moment to type it in on your calculator. It's probably enough time. You get 210. All right. Less possibilities. Less boys, less possibilities. 5 girls. No boys. Okay, so 7, choose 5, times, and then I don't know what's going to happen, but I'd say I got 6 boys and I'm choosing 0 of them. So not sure what that equals. I'm pretty sure this equals 1. Boy, I'm sure going to look silly here if it doesn't. Yes. 6 choose 0 is 1. So there's only one way to have no boys, and that would be to have no boys. All right, so when you do that and you do this one as well, you get 21, okay? And you got to add them all up. So this plus that, and you're going to get 756 ways. Wow. All right, we are just about done here. So we're going to do another one, another couple. I'm a liar. The difficulty with this unit is keeping the types of questions straight. Well, yeah, no duh. It's obvious. That really is the biggest thing. Yeah, for sure. So, 1, how many ways can 3 identical French texts, 4 identical math texts, and 3 identical geography texts be arranged on a shelf? So remember, my warning up here is that I'm giving you 2 questions, and they may or may not be combination questions. So think about it for a second. You know, is this a combination question, or can we do it another way? So I'll give you some time. You know, I can mess around with my light. Check this out. Ooh, what's happening? Ah. Oh, that's better. My light has like a zoom lens. See? It's getting zoomed in. Oh, everything's tunneling in on me. Oh, the math is too much. Pretty neat. Okay. This is a weird video. I love making these things for you guys. Anyways, so we were thinking about this question. It really is like I'm actually in class, eh? And we get sidetracked and everything. And I'm just by myself sitting in an office. That's the funny part. All right, Demiro. So, this is not a combination question. This is actually a question from, I guess, the first day that we started doing this stuff. So this is a question where you got to divide out the identical texts. Okay, so we got all these things lined up on a shelf, and I guess the analog would be like, if you guys remember that Mississippi question, where the question, miss is, oh boy, ippy. Can't remember how to spell it, but remember, we had to divide by the repetitions, right? So like all the S's that repeated, and it had to be factorial. This is the same question, just looks a little different. So if you're going to arrange all these books on a shelf, okay, it doesn't say they have to be arranged in a particular order, but because we have identical books, we're going to end up dividing by all of these numbers factorial. So just count up how many we have. We got 3 plus 4 plus 3. So in total, we got 10 books. Okay, so it's going to be 10 factorial ways to arrange those books. Because I want it to be unique arrangements, I need to divide out all the identical ones. So I'm going to divide by 3 factorial for the identical French ones, 4 factorial, right? 4 factorial for the identical math, and then 3 for the identical geography ones. Okay, and yeah, I guess type that in on your calculator. I didn't. Well, 3 factorial is 6. 4 factorial is 24. You can really save yourself some time if you know those smaller ones. So you get 4,200. Okay. Okay, so that's that question. Probably the easiest way to do it. There are other ways, but it's definitely not a combination. I'm just thinking about that. Maybe you can. You could probably do it with combinations. How many ways can 3? Right. I'm just reading number 2. So this looks like a similar question, but it says, well, 3 different French texts, 4 different math texts, 3 different geography texts. How many ways can they be arranged on a shelf if they must stay together by subject? Okay, yeah, we've done that question before. Okay, so, there's your groups, and we'll just arbitrarily say, in the order in the question, there's my French books, there's my math books. I'm going to spell math because math is cool. And there's my geo books. Okay, so that's a group, that's a group, that's a group. Within the group of the French books, there's 3 different ones. So there's 3 factorial ways to arrange that. Within the math ones, there's 4 factorial ways to arrange those 4 books. And there's 3 geography books, so there's 3 factorial ways to arrange that, okay? Now, generally, if this was on the exam, it'd probably be a 2 or 3 mark question because they would say, well, 1, 2, 3 marks for that. And then the thing that most people forget is, well, I can move the groups around, right? Like I could take the whole French group and the whole math group and change them and then do it that way. So you need to remember there's 1, 2, 3 groups. So there's 3 factorial ways that you can arrange the groups themselves. Okay, so when you go 3 factorial times this, times that, you'll get your answer. Remember, that's just 6 times 24 times 6 times 6. 6, 6, 6. Let's see. 6 times 6 times 6 times 24. Wow. If you're in the business of organizing books on shelves in different ways, there's a lot of things you could do. 5,184. All right. So, hopefully that lesson was entertaining. A final thought. Final thought. Okay. Should it be called a combination lock? Right. Well, we talked about this yesterday. So let's think about this. This was actually a theory question on an exam where they literally asked, why is a combination lock a bit of a misnomer? That was literally the question. So remember, for a combination lock, say the code is 183. Okay. That's the code. If I have a 3, an 8, and a 1, I got the right numbers, right? But I don't have them in the right order. Okay? So remember, a combination is when the order doesn't matter. Okay? So this is like the lottery ticket again. Like if these are the 3 winning numbers on the Lotto Max, and I had this on my ticket, I would win. But on a combination lock, it's not good enough to have just the 3 right numbers. They also need to be in the right order. Okay, so should it be called a combination lock? No. Right? Order matters, and when order matters, it's a permutation. So it should be called a permutation lock. Because, excuse my shorthand, because the order of the code matters. All right. So I highly doubt they'll ever use that one again on the exam, but you never know. So there it is. For the work, obviously, you can do the exercise 8.3, and in your notes booklet, there is some supplementary questions that you can do. Okay, and I believe the answers are attached. So, signing off, it's your good man, DeMuro. Stay fit and have fun.